So for this problem, to find the limits at infinity and if the given contains a radical, so first we need to divide every terms by the highest exponent since the highest exponent is x squared and inside the radical, so therefore divide every terms by the square root of x squared. So this becomes 2x then over the square root of x squared then minus 1 then over the square root of x squared then all over. So also the denominator, so 9x squared plus 4 then over the square root of x squared. Then to simplify, so since square root of x squared is equal to x, so this becomes 2x then over x then minus 1 over x then all over since square root of x over square root of y is equal to the square root of x over y. So for this denominator, this becomes the square root of 9x squared plus 4 over x squared. Then to simplify, so we can cancel now this x. So we have 2, then minus 1 over x, then over. So we can distribute this denominator to every terms. So we have 9x squared over x squared, then plus 4 over x squared. Then to simplify, so we have 2 minus 1 over x, then over the square root. So we can cancel now this x squared. So we have 9, then plus 4 over x to the power 2. Then since for these limits at infinity, so for the limit as x approaches to infinity, and we have the constant over x to the power n, so this is equal to 0. So therefore, a constant over x, so this limit is equal to 0. A constant over x, so this limit is equal to 0. So we have now 2 minus 0 then over the square root of 9 plus 0, and we have 2 over the square root of 9 is 3, so therefore the limit is equal to 2 over 3. Then for this limit, so again divide every terms by the highest exponent. So since the highest exponent is x squared and inside the parentheses, so this becomes the square root of x squared plus 4x minus 3 then over the square root of x squared then all over. So divide every terms by this square root of x squared then plus 2 over square root of x squared. Then to simplify, so we can write this one as one radical. So this is equal to x squared plus 4x minus 3 then all over x to the power 2 then over. So since the square root of x squared is equal to x, so this is x over x then plus 2 over x. Then we can distribute now this denominator to every terms. So we have now the square root of x squared over x squared then plus 4x over x squared, then minus 3 over x squared, then all over x divided by x. This is equal to 1 plus 2 over x. Then to simplify, so we have the square root. This x squared divided by x squared, this is 1. Then plus, so we can cancel now this x and 1x. So this is 4 over x. Then minus 3 over x squared, then all over 1 plus 2 over x. Then for these limits at infinity, so for the constant over x to the power n, this is equal to 0. So the constant over x, this one is 0. The constant over x to the power n, this one is 0. The constant over x is 0. So the remaining is square root of 1 over 1. And the square root of 1 is 1 over 1. So therefore, this limit is equal to positive 1. Then for this given, so we have this x squared inside the radical. So divide every terms by x over square root of x squared, then plus 5 over square root of x squared, then all over the square root of 3x squared plus 5, then over the square root of x squared. Then since square root of x squared is equal to x, so this is x over x, then plus 5 over x, then all over. So we can rewrite this one as one radical. So 3x squared plus 5 over x squared. Then to simplify, so x squared divided by x squared, this is 1. Then plus 5 over x, then over. So distribute this denominator to every terms. So this is 3x squared over x squared, then plus 5 over x squared. Then to simplify, so we have 1, then plus 5 over x, then over the square root. So we can cancel now this x to the power 2. So this is 3, then plus 5 over x squared. Then for these limits of infinity, so a constant over x to the power n, this is 0. A constant over x to the power n, this one is 0. So the remaining is 1 over the square root of 3. Then to rationalize, to remove this radical in the denominator, so multiply every terms by this square root of 3. So 1 times square root of 3, so this is square root of 3, then over square root of 3 times square root of 3, so this is square root of 9. So this limit is equal to square root of 3 over the square root of 9 is positive 3.